Okay. Now see here, this particular diagram body mass, this is a body of mass m, block of mass m, is kept on this surface. So before going to FBD, let's say think of what are the forces that we have learnt. We have learnt number one, gravitational force, afterwards normal reaction, afterwards tension, right? So is there any tension here? No, because there is no rope, string or rod, anything like that. So only normal reaction and gravitational forces we can think of, right? Okay. So what is FBD? Let us think of afterwards. First look into the conditions, like what are all the total number of forces are acting on it. Okay. So this total number of forces are coming into picture. Okay. Now by virtue of mass, there is a downward force, that is mg, right? Okay. This surface exert a force onto this body, that is called a normal reaction. In turn, this body also exert a force downward, that is normal reaction. Is it not? Right. I have not drawn here that n. Okay. Right. So these are all the forces that you have learnt it. Now when it comes to FBD, free body diagram, so like this is the situation, but everywhere we cannot write this diagram. So instead of this, we should go for a diagram which is very feasible and easier for us to understand the things and make the complex thing into simpler. So that's where the concept of FBD comes into picture. See, this is the free body diagram that I have drawn. How I have drawn, I will show you. See, this bigger body object, what I have done is, instead of drawing this entire big, any body under consideration, what we should take is, we should take this as a point object. That I have done it here. This is the point object. You can see it, right? And one more condition. What is that? So this I considered as a point object. Then onto this object, what are all the forces acting on it, that we have to count it. So here this is the normal reaction exerted by this surface, obviously we know it, and this object m also exert a force onto this surface back, that is a counter force exerted by it, that is exerted by this body, that we should not consider. What we should consider? We should consider only that force which is exerted onto this body m, not this is exerting on other things. Okay, clear? What are the total number of forces acting on this? We should count it. Okay, so what is the force acting on it? Now one is normal reaction, which is acting perpendicularly. Okay, that we have taken. Other one is mg downward, which is acting downwards. This is we have taken, right? So only two forces are acting. So this is the point object, and we had made an n on the top and mg on the bottom, right? So this is the pictorial representation, that is we call it as FBD, right? Now let's go for the rules. Okay, now what the first rule says? First rule, body, consider the body as point mass, right? This entire big mass I consider it as a point mass. Second condition, so any body, we need not to draw the entire picture of that whole instrument or a material as such. What we need to do, just consider it as a point object. Let's put a dot like this. This is over. So this is the first condition. Second condition, we will show all forces acting on the body. See, inverted comma, we have written on the body, on body. So as I said, n, it is acted by this, that we should not consider. What total which is acting on the body we should take into account. This is the second condition. Third condition is what? We have to count the number of forces, that is okay. Third one, number of forces on a body is counted with the ground frame of reference. That is most important thing. Now I said the mg is downward, normal reaction is there. Now somewhere here I am standing and I am observing here. I am on the ground and observing it, and that's why this is, I am able to take only two forces. But if I stand on Mars or some other planet and if I observe it, for me this entire earth itself is revolving, there another new force comes into picture. But there again I have to add that force also, but I have not added anywhere. It is because I have considered this entire body to be at rest and I am on the ground surface. So one most of the cases, most important also factor is that number of forces on a body is counted with taking which into account? Ground frame as frame of reference into account. So we should take ground frame of reference in most of the cases, unless it is stated take another reference, then you should go for it. But in 99.99 cases, we'll take what? Ground as the frame of reference. This is the condition, right? So number one, point mass, consider point mass, and second one, count the number of forces acting on the body, and third one, take what is that reference as ground frame of reference. Okay, number of forces should be with respect to the ground frame of reference. Okay, another example. Similarly, another example here is shown. Okay, consider this body. It's an inclined plane. On this inclined plane, a body of mass m is kept. Right. Now, asked to find out the free body diagram. Okay, so this is body under consideration, that I put it in the form of dot. Okay, and this is the normal force. So this is surface, right? Between this surface and this surface, there will be normal reaction. So exerted by this surface onto this body in this normal, so in a perpendicular direction. So that is how I drawn like this. This is the normal force N. Okay, and this is the force which is exerted by the earth, that is gravitational force mg, that I have taken into consideration. And again, mind, what is that? Number of forces on the body is counted with respect to ground frame of reference. Again, where I am standing on the ground and I am observing it. So that is why for me, how many forces are coming? 2 forces, that is N here and it is mg. So here this is the free body diagram of this particular body, right? Okay. Similarly, what we are going to do is some other examples. Let us consider it. Okay. Now come here. Okay. Let's focus this particular object. So this is called as pulley, Atwood machine also we call it as. So this Atwood machine, so this is pulley is hung to this rigid support by one string. Let's consider this string number 1. Okay, and this is being connected by another string or a rope, whatever you call it. So one mass is m and other mass is let's take it as m1 and it is taken as m2, right? Now, and it is stated that it is massless and it is frictionless. Okay, in most of the cases it has been given for massless and frictionless, right? Now you are asked to draw the free body diagram of this one. So how will you do it? Let's take it. Okay, let's focus on this. Right here you can focus it, you can see this. So the same material is there, I have drawn it again here, you can see clearly. Okay, m1 here. So this entire string here, what is the entire string is there? This string is same, only one string is there. This is string number 1. This string is different. This entire string is different. So only 2 strings from here to here. The string is same only, right? Now what I have done is string here. Open the, whenever string comes means which force will come into the picture? Tension, right? Okay. Open the umbrella. This is the tension T. If you have written tension T throughout, this means tension will be same only because of single rope only, no change in the rope. So here tension. So you can again rigid support, rigid body. What is tension here? Open the umbrella here. If you open umbrella like this, tension will be like this, T. Come here, open the umbrella. Umbrella if you open like this, umbrella will open like this. So tension T, right? If you come here, if you open the umbrella, tension T will be downwards, right? So throughout this tension remains same only, right? Okay. And here when it comes, so can you write the same tension T only? No. Here tension is different. So here what is the tension? Let's write it as T1. Okay. Here tension T1, here T, right? And here M1 and here M2. Okay. So now we have drawn tension now. So again here, this is the rigid support. Rigid support means here what is the tension? It will be T1. So open the umbrella like this, it is T1. Now let's take first this particular objects. Okay, this you consider entire pulley as a point object. I have drawn here, you can see it. Okay, this is the pulley, I have drawn it in the point. Okay, right, I mark it as P. On the top, what force is acting? That is T1, that is tension T1. Okay, right. Downward, one force is acting, that is T. Here, this one more force is acting, that is T. So here T and here one more what? T, right? Here on the top T1, here T and here T. Okay, so now if you consider it, so T1 is balanced by 2 T's, T and T. So mathematically how will I represent it? I will represent it like this. Listen here. T1 is equal to T plus T. T1 is equal to T plus T. So T1 is equal to T plus T means what? How much? 2T. So this free body diagram I have drawn it. T1 is equal to 2T. Now come here. Free body diagram of these two objects. Let's take this one, M1. Where is M1? Here, M1. Okay. Where is M2? M2 is here. Okay. So what you, according to the rule, we should take it as a point object. So no need of drawing entire big object M1, just take it as M1 here. Okay, you can see it, point object, right? Okay. On to this. What is that? On the top, what is acting? T is acting. On the bottom, what is acting? By virtue of mass and gravity force, that is called as M1G, M1 and G. So M1G downside, T is topside. So T is balanced by M1G. Is there any normal reaction here? No normal reaction. Okay. So T and top and M1G on the bottom. Right. Now go for M2. M2 is here. What is the top force? That is T. Bottom one, M2G. So now if you take into picture consideration.